Welcome to our YouTube channel Agricultural Engineering. Now we are going to see soil and water conservation structure course. Now without wasting much time, let's go for it. Now type of soil erosion. There are different types of soil erosion. Geologic erosion, sometimes referred to as natural or normal erosion, represent erosion under the cover of vegetation. Then wind erosion, you have seen already this one. Detachment, transportation and redeposition of soil particles by wind. Then this is process of wind erosion, saltation, suspension, surface creep. We have already discussed that one. Then water erosion. Then different type of water erosion: splash erosion, sheet erosion, rail erosion, gully erosion, tunnel erosion, stream bank erosion. Okay, so as already we discussed, but still from exam point of view, these different types of water erosion are important. The sequence of water erosion is important. If you have seen our community section of YouTube, there you will find some of the questions regarding this, and as well as for wind erosion, saltation, suspension and surface creep. This sequence should be remembered, so don't forget this one from exam point of view. Next one is soil conservation. Why need of soil conservation? That is, see here, integrated wasteland development project. See, these are some of the important what we say short forms or full form. They will ask, they will give short forms and you have to answer the full form. So just go through this: watershed development fund, WDF, like that. So you should go through that one. Then they have given the objective of each of this department. You should not go in that much deep, just remember the short form and its long form. Then biological control of soil structures. See, there are three types of soil erosion control structure. One is biological, one is mechanical, and another one is bioengineering. So in biological, erosion is controlled through crops or vegetation. See, mulching, agroforestry, reforestation or afforestation, then crop rotation, then mixed cropping, cover cropping, contouring, strip cropping. So in this case, see, strip cropping, the definition of strip cropping you should know. The definition of contouring also you should know. From exam point of view, they will ask, means dash is the practice of growing alternate strips of row crops and intertilled crops in the same field. The answer is strip cropping. Then conservation tillage. Conservation tillage is any method of soil cultivation that leaves previous crops residue on field before and after planting. Then what are the mechanical methods? Mechanical means construction. So these are construction of bunds: contour bund, graded bund. So when we have to go for contour and when we have to go for graded bund, you should know the slope of each bund. Then different type of terraces comes under mechanical methods. Then bioengineering method. Biotechnical engineering techniques are combined with biological knowledge to build geotechnical and hydraulic structures and to secure unstable slopes and banks. So these are bioengineering techniques: wattle fence, leaf bank protection, live palisades, brush layering, coconut fiber fascines, pre-vegetated mats, live gravel bar stacking. These are some of the bioengineering methods. Now what are physiographic characteristics of watershed? Again, watershed part is coming. So area of watershed, then length of watershed, then slope of watershed, shape of watershed, stream order. See here, here you will find all the definitions in this particular part. Remember this all characteristics, formula and the effect on hydrograph shape. So ignore this effect of hydrograph shape. You should go through these characteristics and its formula from exam point of view. Then what are the steps for watershed delineation? This is somewhat practical approach. It won't be that much important from exam point of view. Then peak rate of runoff, rational method, CIA divided by 360. So in this case, most of the students, what they will do, in exam they will ask I is the intensity, rainfall intensity in per hour, meter per hour, like that. So you should remember, in this case when we are dividing by 360, then your intensity is in per hour, remember this one, and discharge is cubic meter per second. Then the runoff coefficient represent the integrated effect of infiltration, evaporation, retention, flow routing and interpretation, all of these which affect peak rate of runoff. So they have given coefficient C for rainfall rates, particular rainfall rate. Then no, this is not that much important, so let it be. Then you should remember the time of concentration. What is the definition of time of concentration and what is the formula? Tc is equal to 0.0195 into L raised to 0.77 L by H raised to 0.385. So remember this formula. Then limitation of rational method. No, this is somewhat complicated problem, no need to go through these problems. Then runoff estimation, SCS curve method. So we have already gone through this, so no need to see this again. AMC methods that we have seen. Okay, so we have already covered this topic in watershed management. Now this is important topic, weirs, runoff measurement using weir. The proper formula is Q is equal to CL H raised to M, where M is an exponent depending upon the weir opening. So classification of weir, broad crested weirs, a weir that has a horizontal or nearly horizontal crest sufficiently long in the direction of the flow so that the nappe will be supported and hydrostatic pressure will be fully developed for at least a short distance. So this is, here you can say, broad crested weir. In this case your equation will be Q max is equal to 1.71 CD L into H raised to 3 by 2. Now sharp crested weir, there are rectangular weir, Cipolliti weir, then V-notch weir. So remember, this trapezoidal weir is also known as Cipolliti weir, and triangular weir is also known as V-notch weirs. Now what is the formula for rectangular weirs? Discharge is equal to 0.0184 LH raised to 3 by 2, and here you have to consider if one side contraction or both side contraction, then formula will change. Remember this one. You can expect this simple problem in case from exam point of view, because you just have to put the values of each parameter to get the answer or discharge. So you can expect one question from this. So suppressed rectangular weir, then contracted rectangular weir, Cipolliti weir. For Cipolliti weir, Q is equal to 0.0186 LH raised to 3 by 2. See, you can expect this question, 7.3 example. Then V-notch weir, sometimes called as triangular weir. So for it, Q is equal to C into H raised to 5 by 2, or in other words 0.0138 H raised to 5 by 2. So you can expect these questions are problem in your exam. Then flumes. A flume is a stabilized channel section for measuring the flow. So what are the advantage, disadvantage? Then partial flume are devices for the measurement of flow of water in open channels. Remember this, open channel, when depth of flow is less. So see the construction of partial flume. So how they are classified? Very small, small and large on the basis of throat width. Then flow measurement, is there any formula? Then H flume is also there, HS flume, H flume, HL flume. Remember these three types and its specifications from exam point of view. Now open channel flow, what is meant by open channel flow? Is also called as free gravity flow, and is the flow of water induced by the effect of gravity. So what are the different types? Steady flow, unsteady flow, uniform flow, non-uniform flow, laminar and turbulent. So here laminar and turbulent, see, if a Reynolds number is less than 500, the flow is laminar. When it is between 500 to 2000, the flow is transitional state, and flow is turbulent if Reynolds number is greater than 2000. Remember this one, Reynolds numbers, turbulent and laminar flow. Then subcritical, supercritical and critical flow, when we have to say. So this type of flow is depends on Froude number. So see, subcritical flow, Froude number is less than 1. Supercritical flow, Froude number is greater than 1. Now energy and momentum equation, conservation of mass in open channel flow, Q is equal to A into V. See, energy in open channel, this is equation P by W plus V square by 2G plus Z is equal to C. So here in this case, momentum equation in open channel flow, okay, this is not that much important, so we will go for energy and momentum. So specific energy, the total energy of a flowing liquid per unit weight is given by E is equal to Z plus H plus V square by 2G. Then specific energy curve, critical depth, definition of critical depth is defined as the depth of water of flow of water at which the specific energy is minimum. Then specific force, hydraulic jump. So see, different types of hydraulic jump also depends on Froude number. Here they have didn't mention hydraulic jump in detail, so I would like to request you just go through the different types of hydraulic jump based on Froude number. There are different type of hydraulic jump, so you just go through that. From exam point of view, it's important topic. I think it's coming. Wait, here it is there, hydraulic jump or standing wave. So here maybe they have given somewhere types of hydraulic jump. See, angular jump when Froude number 1 to 1.7, weak jump 1.7 to 2.5, oscillating jump 2.5 to 4.5, Froude number, steady jump 4.5 to 9. So these are different types of hydraulic jump. Now design of permanent gully control structure. So see, for a temporary structure is limited life around 3 to 8 years, and all temporary structures should be practiced in G1 type gullies. So if you ask G1 type, G2 type, then you can go through previous lecture. There I have explained what is G1, G2. Then woven wire dams, then brush dams, loose rock dam. These are comes under temporary structure. Then permanent structure, drop structure, G2 type of gully, and downstream fall of water is limited to 3 meter. Then there is drop structure. Then chute structure, G3 type gully, where the depth gully depth is more than 3 meter. Then drop inlet structure, G4 type gullies, and where depth is more than 9 meters. Now components of gully control structure: inlet, main body, outlet. Then selection criteria. Then design procedure, how we should design. So the hydrologic design is one of the aspect to design the permanent gully control structure. Then hydraulic design, then structural design. So I think they have explained this one in detail. Now drop spillway. Drop spillway is a weir structure. Flow passes through the weir opening, drops to an approximately level apron or sealing basin, and then passes into the downstream channel. So what are the different components? So it's quite bit complicated to explain all these structures, so I would like to tell you that you just go through this, what are the uses and material of construction. So you should compare this drop spillway, then drop inlet spillway, then drop design of chute spillway, what is their difference, how they design, what is the formula. So I won't waste that much time to explain all these things. I would like to say that you just go through this with problem with formulas and its just explanation. Now see, here are factors responsible for different type of failure of hydraulic structure. So this you should know: failure are due to overturning, sliding, tension, compression and piping. Then what are the different functions of each component? Again I am telling, this is important topic from exam point of view: function of components of drop spillway. The next one is structural design for drop spillway. This is quite a practical approach, so you can ignore this one. Now drop inlet spillway, conduit, definition of conduit, then what are the use, advantage, limitations, hydrologic design. So just you go through each component and just formula remember. There is no chance of asking any questions by using this formula. So anti-slip collars are primarily provided to check the adverse effect of piping phenomena by increasing the pipe length and cutting short the capillary gradient along a pipe conduit which extends through an embankment. So how to install conduit? Now chute spillway. In chute spillway, what is the use, what are the limitation, what are different components of chute spillway? Now this question you can expect. The chute spillway is to be provided with a straight inlet with peak flow discharge 3.57 cubic meter per second. The depth of flow is to have 1.28 meter. What should be the wear length? Coefficient of discharge is 0.6. So you just have to insert these values in the formula. So as I said earlier, you should know the each component and formula for that particular component. So Q is equal to 2 by 3 into CD into square root of 2G into L into H raised to 3 by 2. Now design of chute spillway. So see here, fraud number, different fraud number, structural design, hydraulic design, hydrologic design. Now water storage structure are the embankment. So what is mean by homogeneous embankment? Homogeneous means, homo means similar, it is composed of one kind of material. Then diaphragm, the bulk of material used for construction of the embankment is previous. A thin diaphragm of impermeable material like concrete, steel or butyl is provided to act as a barrier against seepage. Then zone earth dam, method of construction: rolled fill dam, hydraulic fill dam. So this is method for construction. Then this is toe drain, seepage failure. Now seepage analysis. Seepage is the horizontal flow of water through the soil pore spacing. So most of the time students get confused in seepage and infiltration. So seepage is horizontal flow of water. Then this is somewhat complicated topic, so it's better to ignore. Then phreatic line is the top flow line which separates saturated zone from unsaturated zone and below which positive hydrostatic pressure exists in the dam section. So remember this phreatic line definition. Now how to locate this line? There are some different methods. Then this is important topic, farm pond. So in case of farm pond, there are some criteria. The water depth should be how much, so you should go through that one. And here capacity of pond we can find using trapezoidal formula or Simpson rule. So see, V is equal to H by 3, twice the area of odd contours, 4 times the area of even contours, area of the first and last contour. So this is the formula. Then you can find hydraulic design, then height of embankment, dugout pond, surface pond, upstream ponds, spring or